Which came first, the chicken or the egg? Did the universe have a beginning, and if so, what happened before then? Where did the universe come from, and where is it going?
Luck, well, we have been very lucky. I mean, my family and Stephen and everybody. You have your disasters, but the point is that we have survived. Everybody has disasters, and yet some people disappear and are never seen again. Flying bombs were very alarming. So they came buzzing over, and then they would cut out. And when you heard the bang, you knew it wasn't you, so you went back to your meal or whatever. But one did fall, quite close to our house, and it blew the back windows out, so that the glass was sticking dagger points all out of the opposite wall. When Stephen was born, we decided he'd better be born in Oxford. So while I was staying in the hospital, I went to Blackwell's in Oxford and I bought an astronomical atlas. One of my sisters-in-law said, "This is a very prophetic thing for you to have done."
How real is time? Will it ever come to an end? Where does the difference between the past and the future come from? Why do we remember the past, but not the future?
I can remember the day when we travelled through London and the blackout was over. And the trains, instead of being shut in by blinds, so you just travelled in a train, we were coming over one of the bridges, and all the lights, well, such lights as were left, were on in London, but it was also a completely starry night, and you could see them right over. It was beautiful. I remember we all used to lie on the grass, looking straight up through the telescope and seeing the wonders of the stars. And Stephen always had a strong sense of wonder, and I could see that the stars would draw him, and further than the stars.
I was born exactly 300 years after the death of Galileo. I estimate that about 200,000 other babies were also born that day. I don't know whether any of them was later interested in astronomy.
My first memory is of Isabel pushing a rather antiquated carriage-built pram along North Road with Stephen and Mary in it, sort of looking very large because they had large heads and pink cheeks and they were very noticeable. They all looked different from ordinary people.
I can remember visiting the Hawking home, several times. It was the sort of place where, if you were invited to stay to supper, you might be allowed to have your conversation with Stephen, but the rest of the family would be sitting at the table reading a book, a behaviour which was not really approved of in my circle, but which was tolerated from the Hawkings because they were recognised to be very eccentric, highly intelligent, very clever people, but still a bit odd. My impression of the Hawking family was that they were all like that, except for Stephen, who seemed to be the only normal member of the family.
Stephen used to reckon he knew, I think it was 11 ways of getting into the house. And I could only find 10 of them. I'm not sure where the other way was. On the north side of the house, there was a bicycle shed. It had a door at the front and a door at the back. Above that, there was the window into the L-shaped room. And at the front, you could get sort of round the corner onto the roof. And from that level, you could get onto the main roof. I think one of the ways Stephen could get in was on the main roof. As I say, he was a much better climber than I was. I still don't know what the 11th one was.
Before the 20th century, it was thought that the universe had existed forever, or had been created at some time in the past, more or less as we observe it today. People found comfort in the thought that even though they may grow old and die, the universe was eternal and unchanging.
I gave up playing games with Stephen, when he was ill that time, when he was about 12, because he started taking games terribly seriously. We had Monopoly. And first of all, the Monopoly board sprang railways going across it to add to the complications. And then Monopoly just wasn't adaptable enough. It ended up with a fearful game called Dynasty, which, as far as I can make out, because I say I never played it, went on forever because there's no way of ending it. It was almost a substitute for living, as far as I could make out. It took hours, hours and hours. I thought it was a terrible game. I couldn't imagine anyone getting taken up with that. But Stephen always had a very complicated mind, and I felt as much as anything, it was the complication of it that appealed to him.
When I was in high school, I learned that light from distant galaxies was shifted to the red. This meant that they were moving away from us, and that the universe was expanding. But I didn't believe it. A static universe seemed much more natural. It could have existed, and could continue to exist, forever.
We were discussing the possibility of the spontaneous generation of life. And I think that Stephen made a remark which indicated not only that he'd thought of this, but he'd even also come across some calculations as to how long it might take. At that time, I think I made a comment to one of my friends, John McLenaghan. I think that Stephen will turn out to be unusually capable. I don't think I put it in quite those words, but I made some such remark to him, and he disagreed. And so we made a bet on the subject. In our childish way, we bet a bag of sweets on the issue. And incidentally, I reckon that my bet has come correct, and I think I'm entitled to payment which has not yet been made.
The expansion of the universe suggested the possibility that the universe had a beginning at some time in the past. The point at which the universe may have started out became known as the Big Bang.
The first year he was at St Albans School, he came, I think, third from the bottom. So I said, well, Stephen, do you really have to be as far down as that? And he said, well, a lot of other people didn't do much better. He was quite unconcerned. Somehow, he was always recognised as being very bright. And in fact, they gave him the Divinity Prize one year. That was not surprising, because his father used to read him Bible stories from a very early age, and he knew them all very well. And he was quite well versed in religious things, although I don't think he makes a very great deal of practice of it now. Everybody used to argue theology. That's a good, safe subject. You don't need any facts or distracting things like that. If you go in for arguing, debating, you can quite happily debate about anything, including theology and the existence or otherwise of God. And then someone gets bored, or Journey into Space comes on, or something like that. The argument breaks up.
In an unchanging universe, one can imagine that God created the universe at literally any time in the past. On the other hand, if the universe is expanding, there may be physical reasons why there had to be a beginning. An expanding universe does not preclude a creator, but it does place limits on when he might have carried out his job.
When the family went to India, it was arranged that Stephen should come and live with us for a year. He decided it would be nice that we should have Scottish dancing in the evening. Now, mind you, this was quite an ordinary house, but we had rather a lot of room and a large hall. And so we bought some records and a book about what to do. And Stephen took charge. And he insisted that you put on a jacket and a tie. And then he was the master of the proceedings. And Stephen took it very seriously. But then he liked dancing, you see.
There were 4 physicists in my year. Gordon Berry, Richard Bryan, Stephen, myself. I first remember Stephen on an occasion when Gordon and I went up after dinner to his room to try to find him. And Stephen was up there with a crate of beer, slowly drinking his way through it. He was only 17. He couldn't legally go into a pub. He'd gone up to Oxford ridiculously early.
We used to have what we call a gathering net. We used to organise a beer party and various things like that to gather all these colours, many freshmen as we could get, you see, to get them to join the boat club. And that's how we collected him, you see. But the question always to Stephen was, should we make him a cox at the first date or the second date, you see? Well, coxes can be adventurous, and some coxes can be very steady people, you see. He was rather an adventurous type. Never knew quite what he was going to do when he went out with the crew. I think he used to bring his work down with him into the boat sometimes, you know. His sort of thinking gear was going on different levels.
We were asked to read a chapter 10, in a book called Electricity and Magnetism by Bleeny and Bleeny, an unlikely combination, a husband and wife team. And at the end of that chapter, there are 13 questions, all of them final honours questions. I discovered very rapidly that I couldn't do any of them. Richard and I worked together for the week, and we managed to do 1.5 questions, which we felt very proud of. Gordon refused all assistance and managed to do 1 all by himself. Stephen, as always, hadn't even started. But the next morning, he went up to his rooms at 9 o'clock. And we came back about 12, maybe 12:05. And down came Stephen, and we were in the college gateway in the lodge. "Ah, Hawking," I said, "how many have you managed to do then?" "Well," he said, "I've only had time to do the first 10. And I think at that point we realised that it's not just that we weren't in the same street, we weren't on the same planet.
I once calculated that I did about 1,000 hours work in the 3 years I was at Oxford. An average of an hour a day. I'm not proud of this lack of work. I'm just describing my attitude at the time. An attitude that nothing was worth making an effort for.
He used to produce his work every week for tutorial, and as he never kept any notes or papers or that sort of thing, on leaving my room he would normally throw it in my wastepaper basket. And when he was with other undergraduates at a tutorial and they saw this happen, they were absolutely horrified because they thought he did this work in probably half an hour. And if they could have done it in a year, they wouldn't have thrown it in the wastepaper basket, they would have put it in a frame up on their walls.
Because of my lack of work, I had planned to get through the final exam by doing problems in theoretical physics and avoiding any questions that required factual knowledge. I didn't do very well. I was on the borderline between a first and second class degree, and I had to be interviewed to determine which I should get. They asked me about my future plans. I replied, if they gave me a first, I would go to Cambridge. If I only got a second, I would stay in Oxford. They gave me a first.
I drove Stephen and his young brother out to Woburn Park, and he climbed a tree. He was testing himself out, I think. I didn't realize. And he did manage to climb a tree and to go along a branch of it and to get himself down. I think he began to notice that his hands were less useful than they had been, but he didn't tell us.
UNIV has these square staircases, which are round, but they're square. It was just coming down from one of the rooms. Steve actually fell on the stairs, coming down stairs, and kind of bounced all the way down to the bottom. I don't know if he lost consciousness, but he lost his memory. We took him to either my room or someone's room. The first question, of course, was, who am I? And we told him, you're Steve Hawking. And a minute later, or right away, he would ask again, who am I? Steve Hawking. And then after a couple of minutes, he remembered that he was Steve Hawking. Then we'd say, well, do you remember going down to the bar and having a drink on Sunday night? Or do you remember coxing on the river on Monday? And his memory came back gradually until he could remember the previous day's events and then the previous hour. And then by the end of the 2 hours, he could remember everything. The question was, well, maybe, you've lost some of your mind because of this. And so Steve decided, well, I'll take the Mensa test. We said, of course you'll get into Mensa. But he came back delighted that he was able to get into Mensa, absolutely delighted.
I felt that there were two areas of theoretical physics I might study at Cambridge. One was cosmology, the study of the very large. The other was elementary particles, the study of the very small. However, I thought that elementary particles were less attractive because there was no proper theory. All they could do was arrange the particles in families, like in botany. In cosmology, on the other hand, there was a well-defined theory, Einstein's general theory of relativity.
It was a very cold year, and the ice on Verulamium Pond was frozen there, and we all went skating. And Stephen managed to skate fairly well, but then he and I were close together. He wasn't skating in a very advanced way, but nor was I, if it comes to that. He fell, and he couldn't get up. So I took him to a cafe to warm up, and he told me then all about it. And it was diagnosed. I insisted on going to see his doctor because it seemed to me, however long you're going to live, there's probably something someone can do about it, at least anyhow to make things easier for people. And I won't mention the doctor's name, but I got to see him at the London clinic. And he was rather surprised that I should bother to come round to see him. I mean, after all, I was only Stephen's mother. So he said he was quite nice. I mean, he agreed to see me in a rather grand way. And he said, yes, it's all very sad. I mean, brilliant young man, cut off in the prime of his youth, as it were. But of course, I said, well, what can we do? You see, well, what can we do to sort of, can we get physiotherapy? Can we get anything like that that will help in any way? I said, well, actually, no. There's nothing you can do, really, more or less. And that's it.
Shortly after my 21st birthday, I went into hospital for tests. They took a muscle sample from my arm, stuck electrodes into me, and injected some radio-opaque fluid into my spine, and watched it going up and down with X-rays as they tilted the bed. I was diagnosed as having ALS, amyotrophic lateral sclerosis, or motor neuron disease, as it is also known. The doctors could offer no cure, and gave me 2.5 years to live.
I went into the graduates' common room and looking really for someone to have lunch with. And there was nobody around that I particularly wished to have lunch with. And then lo and behold, Stephen walked through the door. I don't know what he was doing in Oxford either. I've certainly forgotten now. And so Stephen generously went off to buy the drinks and brought them over and put them down on the table. And as he put his pint of beer down, he spilt it. And I sort of said genially, oh, heavens, drinking at this time of day. And he then told me that he'd been in Addenbrooke's for 3 weeks, and they'd done a whole series of tests, and they'd decided what was wrong with him. And he told me very straight and flat that he was gradually going to lose the use of his body, that eventually only his heart and his lungs would still be operating, and his brain, and that they'd told him that eventually he would essentially have the body of a cabbage, but his mind would still be in perfect working order, and he would be unable to communicate with the rest of the world.
My dreams at that time were rather disturbed. Before my condition had been diagnosed, I had been very bored with life. There had not seemed to be anything worth doing. But shortly after I came out of hospital, I dreamt that I was going to be executed. I suddenly realized that there were a lot of worthwhile things I could do if I were reprieved.
I knew perfectly well that he had no faith. And to me, that made it the more difficult, because you must ask yourself, why me? Why this? Why now? But he just totally, flatly accepted that this was what was going to happen to him. And as far as I can gather, at that point, he started to do some work.
At first, there did not seem much point in working at my research, because I didn't expect to live long enough to finish my PhD. However, as time went by, the disease seemed to slow down. I began to understand general relativity and make progress with my work. But what really made a difference was, I got engaged to a girl called Jane Wilde. This gave me something to live for, but it also meant that I had to get a job if we were to get married.
Stephen was already ill. Jane knew it. And it was another instance of Stephen's luck, you know, meeting the right person at the right time. Because Stephen was very, very badly depressed. And he wasn't really very much inclined to go on with his work. I mean, he'd been told he'd only got 2.5 years. What can you do in that time? But meeting Jane really put him on his mettle, and he started to work.
I wanted to understand how the universe began. Einstein's theory of general relativity showed that the universe was expanding. But there was no answer to the crucial question, must there have been a Big Bang, a beginning to time? Then, in my 3rd year at Cambridge, Roger Penrose made his discovery about the death of stars.
I remember talking to this friend, Ivor Robinson, and we were having a sort of very animated conversation. And then we had to cross a road. And as we crossed the road, of course, the conversation stopped. And then we got to the other side. Well, evidently, I had some idea in crossing the road, but then the conversation started up, and it got completely blotted out of my mind. And it was only later, after my friends had gone home, and I began to have this strange feeling of elation, feeling wonderful. And I couldn't figure out why on earth I should feel like that. So I went back over the day thinking all possible things which might have contributed to such a feeling. And then gradually I unearthed this thought which I'd had while crossing the street.
Penrose announced this result, that when stars collapse indefinitely, they will become singular, as long as some very broad conditions are satisfied that everybody would have regarded as reasonable. And I remember Stephen Hawking, who was then approaching his 3rd year as a research student, saying, "What very interesting results. I wonder whether they could be adapted to understanding the origin of the universe." And what he had in mind, you see, was that if just mentally you reverse the sense of time, you can think of the expanding universe as a collapsing system. It's a bit like a giant, very giant star collapsing.
Roger Penrose proved that a dying star, collapsing under its own gravity, eventually shrinks to a singularity, a point of infinite density and 0 size. I realized that if I reversed the direction of time so that the collapse became an expansion, I could prove that the universe had a beginning. But my proof, based on Einstein's theory of general relativity, also showed that we cannot understand how the universe began, because it showed that all scientific theories, including general relativity itself, break down at the beginning of the universe.
We had this meeting at the Institute of Space Physics in New York. I said before we reach a final conclusion, we ought to throw into the pot still another object, a gravitationally completely collapsed object. Well, after you've used the phrase, a gravitationally completely collapsed object, 10 times, you conclude you've got to get a better name. So that's when I switched to the word black hole.
The word black hole, which John Wheeler coined, suddenly caught on. Everybody adopted it, and from then on, people around the world, in Moscow, in America, in England, and elsewhere, could know they were speaking about the same thing. And not only that, but it suddenly, the whole range of concepts got through to the general public, and even science fiction writers all of a sudden could talk about it.
Tonight, my friends, we stand on the brink of a feat unparalleled in space exploration. If the data on my returning probe ship matches my computerized calculations, I will travel where no man has dared to go.
Into the black hole?
In, through, and beyond.
Why, that's crazy. Ha! Impossible.
As a massive star contracts, its gravity becomes so strong that light can no longer escape. The region from which nothing can escape is called a black hole, and its boundary is called the event horizon. One might say of the event horizon what Dante said of the entrance to hell. Abandon all hope, ye who enter here.
I was once asked to actually be an adjudicator on an essay of which the subject was how to fall through a black hole and live. Now, the problem I had was that I wouldn't know how to give out the prize, because if I said, well, that looks like a good essay, the only real way of showing that this was right was to actually follow it, to do the experiment and fall in. But then, having fallen in, I would assume taking the person who wrote the essay with you, the question would be, how do you tell the rest of the world? Do you take the prize in with you that you give to them? And what do they do with it when they get to the center?
Believe me, I've been waiting a long time for someone like you to record this moment.
Thank you, Doctor.
Then I'm ready. Ready to embark on man's greatest journey.
Certainly his riskiest.
The risk is incidental compared to the possibility to possess the great truth of the unknown. There, long-cherished laws of nature simply do not apply. They vanish.
And life?
Life? Life forever.
If you were watching an astronaut foolhardy enough to jump into a black hole at some time on his watch, say 12 o'clock, he would cross the event horizon and enter the black hole. But no matter how long you waited, you would never see the astronaut's watch reach 12 o'clock. Instead, each second on the watch would appear to take longer and longer, until the last second before midnight would take forever. Thus, by jumping into a black hole, one could ensure that one's image lasted forever. But the picture would fade very rapidly and grow so dim that no one could see it.
As somebody disappears into a black hole, as seen from the outside, it looks as though the time actually slows down, and the person becomes who's moving. At least he's thinking, he's moving, he's perhaps talking in his spaceship at a normal rate, seems to slow down and ends up by being frozen in a particular position, as seen by somebody watching him from the outside. And as seen from the outside, you never see what happens after that.
The astronaut wouldn't notice anything special when his watch reached midnight, and he crossed the event horizon into the black hole. Until, of course, he approached the singularity and was crushed into spaghetti.
One can fall through this event horizon without feeling anything, without noticing it. After about a week of falling, one begins to feel the pinch, and one extends longer and longer and gets slightly thinner. And, of course, one begins to get squeezed, until one gets very long and very thin and rather nasty. By the end of 2 weeks, one's fallen right into the center, and one is, of course, dead.
Before you lose sight of the outer world, you would see things happening, and you would see them at a greater rate, so that it would look like a firework display. The frustration would be that although you would be able to see everything that happens in the future, it would be going so fast that from a scientific point of view, you would have no time to analyze it. You wouldn't be able to take it in. And eventually, things would be going off so fast, and it would be so explosive that you yourself would be destroyed by the explosion, and that would be the end. But it would be a very exciting way to end one's life. It would be the way I would choose if I had the choice.
In the long history of the universe, many stars must have burned up their nuclear fuel and collapsed in on themselves. The number of black holes may be greater than the number of visible stars, which totals about 100,000 million in our galaxy alone. We also have evidence that there is a very large black hole at the center of our own galaxy.
Friends ask me, well, if a black hole is black, how can you see it? And I say, have you ever been to a ball? Have you ever watched the young men dressed in their black evening tuxedos and the girls in their white dresses whirling around, held in each other's arms, and the lights turned low, and all you can see is the girls? Well, the girl is the ordinary star, and the boy is the black hole. You can't see the black hole any more than you can see the boy, but the girl going around gives you convincing evidence there must be something there holding her in orbit.
One evening, shortly after the birth of my daughter, Lucy, I started to think about black holes as I was getting into bed. My disability makes this rather a slow process, so I had plenty of time. Suddenly, I realized that the area of the event horizon must always increase with time. The increase in the area of the event horizon was very reminiscent of a quantity called entropy, which measures the degree of disorder of a system. It is a matter of common experience that disorder tends to increase with time if things are left to themselves.
Jacob Bekenstein came into the office one day. Jacob, I said, it always troubles me when I put a hot teacup next to a cold teacup. I've increased, by letting heat flow from one to the other, the amount of disorder in the universe. But Jacob, if a black hole swims by, and I drop both teacups into this, I've concealed the evidence of my crime, have I not? Bekenstein's a man of great integrity, and he looked troubled, and he came back to me later, and he said, no, you have not concealed the evidence of your crime. The black hole records what's happened to you. Stephen Hawking read the paper in which Bekenstein announced this result, thought it was preposterous, and decided to prove it was wrong.
My discoveries led Jacob Bekenstein to suggest that the area of the event horizon actually was the entropy of a black hole. But there was one fatal flaw in Bekenstein's idea. If black holes have an entropy, they ought to have a temperature. And if they have a temperature, they ought to give off radiation. But how could they give off radiation if nothing can escape from a black hole? As it turned out, Bekenstein was basically correct, though in a manner far more surprising than he, or anyone else, had expected.
As he gradually lost the use of his hands, he had to start developing, carefully choosing research projects that could be tackled and solved through geometrical arguments that he could do pictorially in his head. And he developed a very powerful set of tools that nobody else really had. So in some sense, when you lose one set of tools, you may develop other tools, but the new tools are amenable to different kinds of problems than the old tools. And if you're the only master in the world of these new tools, that means certain kinds of problems you can solve and nobody else can.
My work up to 1973 was in general relativity and was summarized in a book I wrote with George Ellis called The Large-Scale Structure of Space-Time. Even then, it was difficult for me to write things down. So I tended to think in pictures and diagrams that I could visualize in my head.
I remember visiting Stephen and Jane at their home in Cambridge. After supper in the evening, when it was time for Stephen to go to bed, Jane insisted, and Stephen acquiesced, I guess this was standard, that Stephen make his way up. I've forgotten whether it was one flight of stairs or two flights of stairs alone, and this was a period when he could no longer walk. The way he got up the stairs was he grabbed hold of the pillars that support the banister and pulled himself up the stairs with the strength of his own arms, dragging himself up from the ground floor on up to the second story in a long, arduous effort. Jane explained that this was an important part of his physical therapy to maintain his coordination and strength as long as possible. At first, it was sort of heart-rending to watch what appeared to be the agony of pulling himself up the stairs until I understood. It's just part of life, pulling himself up the stairs like that.
General relativity is what is called a classical theory. It predicts a single definite path for each particle. But according to quantum mechanics, there is an element of chance or uncertainty. A particle does not have just a single path through space and time. Instead, there is an uncertainty principle, according to which both the exact position and velocity of a particle can never be known. I began investigating the effect quantum mechanics might have on particles near a black hole. I found that particles could escape from a black hole, that black holes are not completely black. At first I didn't believe it. But when I redid the calculations, I couldn't get the effect to go away.
I met Martin Rees, and he was shaking with excitement. And he said, have you heard what Stephen has discovered? Everything is different, everything has changed.
I was still unsure of my discovery, so I only told a few colleagues. But word soon spread. Roger Penrose phoned up on my birthday. He was very excited and went on so long that my birthday dinner got quite cold. It was a great pity because it was goose, which I'm very fond of.
To me, it's a miracle because it's a complicated and messy calculation. We can now do these things very much better, and it's more transparent what happens. But out of this messy calculation, he showed that black holes aren't black with this quantum mechanical effect. There was a residual radiation. Stephen came to a meeting, and people were flabbergasted. And I remember someone getting up and saying, "You must be wrong, Stephen. I don't believe a word of it."
I once said that I was unhappy with the explanation given in terms of negative energy particles being created. But I feel this is part of the controversy of science. You must have the give and take, and I'm delighted to be able to be part of that. I mean, that's what makes it fun. You know, if you all sat down and said, oh, lovely, when you do have niggling questions in your minds, that's not doing a service to science. But I was not antagonistic to it in any way, except for that one time when I questioned.
I finally convinced myself that black holes radiate when I found a mechanism through which this could happen. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole. Einstein never accepted quantum mechanics because of its element of chance and uncertainty. He said, God does not play dice. It seems that Einstein was doubly wrong. The quantum effects of black holes suggest that not only does God play dice, he sometimes throws them where they cannot be seen.
He says himself that he wouldn't have got where he is if he hadn't been ill. And I think that's quite possible, because it's like Johnson said, you know, knowledge that you're to be hanged in the morning concentrates the mind wonderfully. And he has concentrated on this in a way that I don't think he would have done, because he always took a great interest in a lot of things in life. And I don't know that he'd have applied himself quite the same way if he'd been able to get around as he used to do. So in a way, no, I can't think anyone's lucky having an illness like that even so. But it's less bad luck for him than it would be for some people, if you see what I mean. Because he can so much live in his head.
When I lived with the Hawking family, I would usually get up around 7:15 or 7:30 and take a shower, and then read my Bible some in the morning and pray. And then I would go down at 8:15 to get Stephen up. And then at breakfast, I would often tell him what I'd been reading in the Bible, hoping that, you know, maybe this would eventually have some influence. So then we would go into work, and usually we'd go in and see if there were any scientific papers that people send out. And I did discover that despite Hawking's great brilliance, he does read quite slowly. I mean, I could read about twice as fast as he. But of course, the point is, he would have to read to remember it, because it would be very difficult for him to go back and access the thing. Whereas I could skim the paper rather quickly and say, is there something interesting in this? If I wanted to work on it, I could pick the thing up and look at it.
Black hole radiation has shown us that gravitational collapse is not as final as we once thought. If an astronaut falls into a black hole, he will be returned to the rest of the universe in the form of radiation. Thus, in a sense, the astronaut will be recycled. However, it would be a poor sort of immortality, because any personal concept of time would come to an end as he is torn apart inside the black hole. All that would survive would be his mass or energy.
One year, the Hawkings took me along when we went to a cottage in Wales near the River Wye. And this cottage was up a hill, and there was a bit of a paved little sidewalk that went up to the cottage, which I had not been up, and of course I wanted to do it in the least number of trips that I could imagine. So we put Stephen's batteries under his chair. I mean, his wheelchair has space for batteries, and put extra batteries under there, which Stephen didn't realize he had, that I'd put under there. So he didn't realize this wheelchair was as heavily laden as possible. So Stephen got quite a bit ahead of me, and then he was turning the corner to go around to his house, but that was on a slope, and so I looked up and I noticed Stephen's wheelchair was slowly tipping backward. And of course I was about 10 meters away and tried to run up there, but I was not able to get there nearly rapidly enough before he toppled over backward into the bushes. And so it was a bit of a shocking sight to see this master of gravity getting overcome by the weak gravitational force of Earth.
One of the worst things for me would be having people there all the time, never alone. I mean, I couldn't bear that. And yet he finds things funny, and he enjoys life, and he goes dashing about all over the place. And I think this is tremendous. But it's a sort of courage that I haven't got, and his father hadn't got it. And we cannot but admire it, but wonder how on earth he got it, really.
There must have been 50 people there. And I was standing off in a corner, sort of watching quietly for a few minutes, relaxing. And Stephen was over there not far from me. Jane walked over to Stephen and looked at him, and he was sitting there with his head in his lap, like only Stephen can put his head in his lap. And Jane said to Stephen, "You look miserable, Stephen. Sit up straight. Some of your guests don't understand that you're sitting there thinking about physics and having a wonderful time. It looks like you're in pain. Sit up straight and go talk to your guests."
In 1979, I was elected Location Professor of Mathematics. This is the same chair once held by Isaac Newton. They have a big book, which every university teaching officer is supposed to sign. After I had been Location Professor for about a year, they realized I had never signed. So they brought the book to my office, and I signed with some difficulty. That was the last time I signed my name. My interest in the origin and fate of the universe was reawakened when I attended a conference on cosmology in the Vatican. Afterwards, we were granted an audience with the Pope. He told us that it was all right to study the evolution of the universe after the Big Bang, but we should not inquire into the Big Bang itself, because that was the moment of creation, and therefore the work of God. I was glad that he did not know the subject of the talk I had just given. The possibility that the universe had no beginning, no moment of creation.
There were theories in the early 70s, in fact the first type of creation theories, where the people concerned started off with a fixed external space and time, which, as it were, for eternity was empty. And then suddenly, for some unknown reason, the universe nucleates at a particular point, and then bang, it blows apart. But the trouble is that when space and time appear in the classical theory, that actual point itself is a singular point in the mathematics. The mathematics breaks down, and so you cannot in fact use that to give you a creation theory.
If one goes back in time, one comes to the Big Bang singularity, where the laws of physics break down. But there's another direction of time that one can go in, which avoids the singularity. This is called the imaginary direction of time. In imaginary time, there need not be any singularities which form a beginning or end to time.
When you come to imaginary time, you have this rather peculiar possibility of having a now, as it were, without necessarily having a sort of a chain of past moments. If we start where we are at the moment, start running backwards in time, as it were, then for a long time things work perfectly normally. But then as you begin to get further and further back towards what would be the origin point in the conventional real-time picture, you find that the nature of the time changes, that the imaginary component becomes more and more prominent, until in the end what ought to have been the singular point in the classical theory just gets smoothed away, and you have this sort of beautiful picture, these sort of bowls. The creation of the universe is pictured as where we are now, in a smooth sort of bowl of the past, where there's no initial point, just a sort of smooth shape.
So long as the universe had a beginning, we could suppose it had a creator. But if the universe is completely self-contained, having no boundary or edge, it would neither be created nor destroyed. It would simply be. What place, then, for a creator?
What we can really say is that the universe is, because it's a self-consistent mathematical structure. There's no past, because unlike the creation of the point scenario, there's nothing for it to be created in, you see. So to say it's created from nothing is actually a little bit of a misnomer. It's a misleading use of the word nothing. It's not just that there was empty space in which the universe appeared, which you might call nothing. There was really nothing at all, because there wasn't even a creation event. You see, the use of a past tense in a verb becomes inappropriate in these theories. Unfortunately, tenses were set up when people believed in real time, of course, and we don't yet have a linguistic form to describe tenses in imaginary time.
The word time was not handed down from heaven as a gift from on high. The idea of time is a word invented by man, and if it has puzzlements connected with it, whose fault is it? It's our fault.
Where does the difference between the past and the future come from? The laws of science do not distinguish between the past and the future. Yet, there is a big difference between the past and future in ordinary life. You may see a cup of tea fall off a table and break into pieces on the floor, but you will never see the cup gather itself back together and jump back on the table. The increase of disorder, or entropy, is what distinguishes the past from the future, giving a direction to time.
He fell ill in Switzerland. When he came back, he was on a ventilator. Because he's on a ventilator, you've got a tube down your throat and therefore you can't speak, just for that reason. For that period, which may have been a couple of months, I spent probably 1 in 2 nights, 1 in 3 nights at the hospital. Because when he was in hospital, he couldn't communicate with the nurses. I mean, it's not just like being seriously ill, but you're in a position where the nurses couldn't understand what Stephen wanted. If Stephen was uncomfortable, they couldn't tell why.
Before I caught pneumonia, my speech had been getting more slurred, so that only a few people who knew me well could understand me. But at least I could communicate. I wrote scientific papers by dictating to a secretary, and I gave seminars through an interpreter. And then, a tracheostomy operation removed my ability to speak altogether.
After a long time, well, it seemed like a long time, somebody came up with this brilliant gadget. They didn't have it at the Cambridge Hospital. They got it from somewhere in London. This was high technology, how you can communicate with a person with no voice. It's a plastic piece of perspex about so big, and you've got the letters of the alphabet arranged like that and a hole in the middle. And you hold it up between you and the other person, and they look at a letter, and you can see, of course, which letter they're looking at most of the time. Sometimes you can't quite be sure. And so you get the patient to spell out what they wanted. You know, so each letter, they have to look to pick out the A, and you say A, you get it right. It's like a guessing game. Stephen wasn't willing to accept that he wasn't going to speak again. And he thought that he would be giving in by trying to find a method of communicating other than speech. And I remember I went in one evening, and this was the first time that he asked to be gotten out of bed to use the computer. Sometimes they would sit him up so that he wasn't lying in the bed all the time, as you do with a patient. But this time when I turned up, he asked the nurse, could he be gotten out of bed? So he could use the computer, and he did. And I remember the first thing he typed on there, after saying hello, Stephen's always very polite about things like that, was, will you help me finish my book?
A computer expert in California heard of my plight and sent me a computer program called Equalizer. This allowed me to select words from a series of menus on a screen by pressing a switch in my hand. These words could then be sent to a speech synthesizer attached to my wheelchair. Much to my surprise, I found I was able to communicate much better than before.
When eventually he went home from hospital, again, he was told he needed 24-hour nursing, and everyone was saying, well, how's he going to go in and do work? Is he going to trail around with a series of nurses after him working in the office? And of course he did. I mean, they talked originally of him working at home, which he wasn't happy with. And so after a period of recuperation at home, he just decided to go back into the office. And he would make the trip from his house to the office, which is, I don't know, half a mile in his wheelchair, with a nurse walking along with him. And this is at the time when he was still driving around with the bag and the nasal drip. Going into the department, working, going back home.
I began to wonder what would happen when the universe stopped expanding and began to contract. Would we see broken cups gather themselves together off the floor and jump back onto the table? Would we be able to remember tomorrow's prices and make a fortune off the stock market? It seemed to me the universe had to return to a smooth and ordered state when it recollapsed. If this were so, time would go backwards when the universe began to collapse. People in the contracting phase would live their lives backward. They would die before they were born, and get younger as the universe got small again. Eventually, they would return to the womb.
He gave me my first problem to do. He asked me to look at this mathematical problem, and usually when he gives a problem, he has a good idea of what the answer should be. And I went to look at it, and it took me a few months to understand what was it about. And I came back and I said, Stephen, I get this answer. And he said to me, no, that is not what I expected. I said, Stephen, that's what I get. So I went to the blackboard, explained him to what it does. He said, did you think about that particular case? I said, oh, no, I didn't. So I went back, I calculated what he talked to me about, came back a few weeks after, and I said, Stephen, I don't get this thing. I still get the same answer I had originally. So he said to me, no, this doesn't work. Did you think about that? I said, oh, no, I'd forgotten about that particular case. So I went back to the drawing board and started calculating again. And again, got the same answer. So I went back to see Stephen, and this dragged on for about 2 or 3 months. Finally, he said to me, maybe one of your approximations is not valid. So me and a colleague decided to do the thing with computers. And then this takes a lot of time to write the programs and to be sure the program was correct. We get the answer, and it was still the way that I had said before, and not the way that Stephen had said. So we went to see Stephen, and we say, you see, again.
I had made a mistake. I had been using too simple a model of the universe. time will not reverse direction when the universe begins to contract. People will continue to get older, so it is no good waiting until the universe recollapses to return to our youth. Einstein once asked the question, how much choice did God have in constructing the universe? If my proposal that the universe has no boundary is correct, he had no freedom at all to choose how the universe began. He would only have had the freedom to choose the laws the universe obeyed. This, however, may not have been all that much of a choice. There may well be only one unified theory that allows for the existence of structures as complicated as human beings, who can investigate the laws of the universe and ask about the nature of God.
I don't know how clear-cut these experiments are, but they're experiments that have been done on sort of the timing of consciousness, and they seem to lead to a very odd picture which doesn't even quite make consistent sense. Whether refinement of these experiments might actually get rid of this kind of anomaly, I'm not sure, but it does look a little as though there is something very odd about consciousness, and somehow almost as though the future affects the past in some way, over a very tiny, limited scale, but something maybe of the order of a reasonable fraction of a second. And there's no reason to believe that one's conscious experience shouldn't be part of somebody else's at some other stage. I mean, I don't know if it's fair to say what happens after one dies, but you could. It's a plausible picture that you could be somebody else, and that somebody else could be somebody that lived in the past, not in the future.
Even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Why does the universe go to all the bother of existing? Is the unified theory so compelling that it brings about its own existence? Or does it need a creator? And, if so, who created him?
I think I would say that the universe has a purpose. It's not a somehow just there by chance. I mean, I think it's, yeah. So I mean, some people, I think, take the view that the universe is just there and it sort of runs along, and it's a bit like it just sort of computes, and we happen somehow by accident to find ourselves in this thing. But I don't think that's a very fruitful or helpful way of looking at the universe. I think that there is something much deeper about it.
In real time, the time in which we live, the universe has two possible destinies. It may continue to expand forever, or it may recollapse and come to an end at the Big Crunch. It would be rather like the Big Bang, but in reverse. I now believe that the universe will come to an end at the Big Crunch. I do, however, have certain advantages over many other prophets of doom. Whatever happens 10 billion years from now, I don't expect to be around to be proved wrong.
Of all the pictures that I know, the simplest of any cosmology is that in which the universe is closed, has a finite lifetime, and collapses with the same kind of collapse that a black hole does. If it should turn out that indeed the universe is limited in its life. How is that different from the life of each one of us?
On the evening of Tuesday, March 5th, at about 10:45, I was returning to my flat in Pinehurst. It was dark and raining. I came up to Grange Road and saw headlights approaching, but judged that they were far enough away that I could cross safely. The vehicle must have been traveling very fast, for when I got just past the middle of the road, my nurse screamed, "Look out." I heard tires skidding, and my wheelchair was struck a tremendous blow in the back. I ended up in the road, with my legs over the remains of the wheelchair. The accident destroyed my wheelchair and damaged my computer system with which I communicate. I required 13 stitches in my head, but I was able to go back to work several days later.
The memories I have are very much kind of visual pictures of what Stephen was, of seeing Stephen in certain situations. He was always moving, always, well, hardly ever still. It was the same thing about his face and gesture, which he used a great deal, I should say, but it's only a memory. I found some photographs recently, which reminded me of the general look of everybody. But I must say, Stephen looked very much like he does now, if one thinks of him like that.
He does believe very intensely in the almost infinite possibility of the human mind. You have to find out what you can't know before you know you can't, don't you? So I don't think that thought should be restricted at all. And why shouldn't you go on thinking about the unthinkable? Somebody's got to start sometime. I mean, think how many things were unthinkable a century ago. And yet people have thought them. And often they also seem quite unpractical. So not all the things Stephen says probably are to be taken as gospel truth. He's a searcher. He's looking for things. And if he is, sometimes he probably talks nonsense. Well, don't we all? But the point is that people must think. People must go on thinking. They must try to extend the boundaries of knowledge, and they don't sometimes even know where to start. You don't know where the boundaries are, do you? You don't know what your taking off point is.
If we do discover a complete theory of the universe, it should in time be understandable in broad principle by everyone, not just a few scientists. Then we shall all, philosophers, scientists, and just ordinary people, be able to take part in the discussion of why it is that we and the universe exist. If we find the answer to that, it would be the ultimate triumph of human reason. For then we would know the mind of God.